Double and half angle identities for trigonometry algebra 2 trig regions. So function of double angles, function of half angles. The good news here is that all of this and all of this is going to be given to you on a reference sheet on the regions. So you do not need to memorize any of this. Everything we've done up to this point in trigonometry and pretty much the whole course, you've had to memorize. Quadratic formula, tangent, sine over cosine, sine squared plus cos squared equals 1. All of that, not on the reference sheet, must be memorized. This stuff, however, this is on the reference sheet, so this will be given to you on my test, and this will be given to you for the regions. So you do not need to worry about that, which is nice because it would be kind of crazy to memorize all of these different formulas. And the same goes for what we're doing in the next video, the sum and difference identity formulas. Actually, let me take a quick second and show you what the reference sheet looks like. So let me pull that up here. And we really haven't gotten to any of this stuff yet. It's really the end of the course. So here are the double and half angle identities that we're going to do. This is what we're doing in this video. All of this is what we're covering in this video. All of this is going to be covered in the next video. The area of a triangle, law of cosines, law of sines, that's in the next chapter. And then series, these two things about arithmetic and geometric series, that's in the next chapter after that. And then there's this whole thing, and then there's this weird whole looking curve thing down here. That's part of our statistics chapter. So all of this we have yet to cover. We're just now starting with our first thing on our reference sheet. But this reference sheet, I'm going to give you a copy of this. It may even be stapled to the back of your packet now. I don't remember if I included one or not. But this will be given to you on every test from now on. And you're going to be using this pretty much every day in class. So you're going to want to have it handy. Towards the end of the year, we'll start filling in different formulas, things to add to it. Like I said, sine squared plus cos squared equals 1 is not on there. So we're going to put it on there ourselves. We're going to practice filling in certain things. So this is your regions reference sheet that you're going to get very used to. But anyways, I gave them to you because we only needed a couple of them this time. So I gave them to you in the top page here as a reference. So a lot of what you're going to be doing today is when you see this, you're going to write this. When you see this, you're going to write this. And then you're going to use those formulas to solve problems. Like this first question. If sine A equals 2 over 3, where angle A is between 0 and 90, what they're really telling us here is quadrant 1, what is the value of sine 2A? Now, for these problems on the regions, it's not going to say, go on the reference sheet and look at sine 2A. You have to recognize that as, oh, that's a reference sheet thing. So that's an identity. That's a double angle identity that's on the reference sheet. And you go to the reference sheet at the back of your regions and check out sine 2A and write down what it is. So you do need to know, recognize that it is a reference sheet identity. But anyways, so sine 2A is 2 sine A cos A. So we're going to write this down as 2 sine A cos A. And now what I'm going to try to do is replace sine A and cos A with numbers. And they gave us one of those. They gave us that sine A is 2/3. So that's 2 times sine A and cos A. And we're pretty much always going to replace sine A and cos A with fractions, ratios, stuff like that. So sine A I can replace with 2 over 3. But this is where the problem comes in, is we do not have cosine A. And that's really the problem of the problem, is we have to figure out what cosine A is so we can complete the identity. And so this is why they tell us we're in quadrant 1, because I could draw a triangle in quadrant 1, label theta in there. Sine is opposite over hypotenuse, so that would be 2 over 3. And now I'm finding this adjacent x value here. I'll call it x. Little Pythagorean theorem, x squared plus 2 squared equals 3 squared. X squared plus 4 equals 9. X squared equals 5. X equals plus or minus the square root of 5, but we know because we're in quadrant 1, it's going to be positive, so it's rad 5. And now that I know that, I can do cosine of theta, or we're using a here instead of theta, but it's the same thing. It's just the variable for the angle. So we're actually using a, not theta, but that's okay. So now that I have the adjacent over hypotenuse, cosine is rad 5 over 3. So some of these problems you'll need to do this. Sometimes we'll give you enough information in the problem that you just plug it in and simplify. Sometimes you'll have to find a piece of it, which is going to happen. So notice I put that 2 over 1. This is 3 fractions being multiplied. I could just multiply across the top, across the bottom. So 2 times 2 times rad 5 is 4 rad 5. You can multiply the 2 times 2, but not the rad 5. 1 times 3 is 9. So 4 rad 5 over 9 is my final answer. I see if it can be simplified. It cannot. So a lot of it is just take a look at this, find its identity, write that down, and then fill in the values that you can, and you may have to draw a little picture and find a missing value now and then. Let's look at a couple other problems. Sometimes it's algebra type stuff like this with numbers and fractions, and sometimes it's identities like what we did yesterday. So I have to recognize this, sine 2a, and I go back, all right, what's sine 2a? Well, it's the one we just used. It's 2 sine a cos a. So I'm going to replace that with 2 sine a cos a. And 2 cos squared. Now this is not a double identity. That's a little confusing because it is 2 times, but if the 2 were here, then that would be an identity. The 2 in the front, that's just a coefficient. So that's not the same thing as cos 2a. So 2 cosine a is not the same thing as cosine 2a. Let's keep that in mind. Why, maybe you're asking? Well, if you think about it for a second, that cosine 60 equals 1/2, right? That's one of those common angle ratios we know. So 2 cosine 60 is equivalent to 2 times 1/2, which is equivalent to 1. However, cosine 2 times 60 is actually multiplying 2 times the angle. So that's cosine 120. And cosine 120, well, let's see, that's quadrant 2. It's 60 away. It would be negative 1/2. You can type it into your calculator if you don't trust me, but negative 1/2 and 1 are not the same thing. So basically, when you have a number in front of the function, like 2 cosine, that's 2 times the ratio of cosine 60. But 2 times, the 2 after the cosine, that's 2 times the angle we're doing the cosine of. So it's not the same thing. All right, but anyways, back to our problem here. So 2 times cosine squared a. Can we simplify this? We can. We can get rid of our 2's, 2 over 2. And then cosine a over cos squared. Remember, that's like x over x squared. You can get rid of an x on each side, and you're left with 1 over x. Same deal here. I could cross out this cosine and cross out the squared of this one. So what I'm left on top is a sine a over a cosine a. And sine over cosine is tangent a. B. So sometimes you have double angle stuff where it's, like I said, fractions, where you got to plug fractions into the identity like we did here. Sometimes it's incorporated into the identities we were doing in the previous video. Sometimes it comes up in trig equations, so it could come up in a couple of different ways. But let's do one more quick example of, this time, a half identity. So this problem is giving us, it's a positive acute angle. Again, they're kind of hinting at quadrant 1. Cosine x equals 1/9. What's the value of cosine half x? Again, you got to recognize that as a reference sheet identity. So what is cosine half? What's the identity? So let me flip back. Here it is, right here. Plus or minus the square root of 1 plus cosine over 2. So plus or minus the square root of 1 plus cosine a over 2. All right, so all I need to fill in this problem is cosine a, which they gave us. Like I said, sometimes you have to find, sometimes we'll give you enough. This is a problem where they gave us enough information, so I just need to replace cosine with what I have. So I actually don't need to find anything here. The plus or minus is because you're not sure what quadrant it is, but because we're in quadrant 1, it's going to be positive, so I could just drop that. And replace cosine with 1/9. So I have 1 plus 1/9 over 2. You could do the algebra here in your calculator if you'd like. I think a lot of you probably will. What's 1 plus 1/9 divided by 2? Well, 1 plus 1/9 is 10/9. Divided by 2 is 10 over 18. And 10 over 18 simplifies to be, divided both by 2, 5 over 9. And then I can square root the top, and I can square root the bottom, but the square root of 9 can be simplified, so I end up with simply a rad 5 over 3. Like I said, getting down to the 5/9 part here, I think you could, if you're careful with parentheses, you could just type that whole thing into your calculator, do it piece by piece. But then once you get it down to a single fraction, do the square root top, square root bottom. You may have to rationalize the denominator somewhere along the way, but that's why the answer is going to be D. All right, so we'll practice these double and half identities tomorrow.